Algebra 1, Lesson 6, Variables. In this lesson, we are going to start talking about variables. This is the part of math where we start to move away from dealing with simple integers, like -2, 3, 5, etc., and start dealing with numbers that are initially unknown. We generally represent unknown values with the letter x. X could be any kind of number from any of the number sets depending on what kind of problem we're solving. So it is not always limited to just real numbers. But in this course, they will be representing real numbers. When we are working on a problem that has more than one or multiple unknown values, we are open to use other letters of the alphabet to represent those values. We could use whatever letters we are comfortable with, but there are conventional letters and symbols that we use to represent certain categories of unknown values. Here is a list of some of the variable naming conventions that are widely used over various branches of math and science. For angle measures, we use the symbols theta, beta, and delta. For exponent, or sums, values we use letters like lowercase k, m, n, and I. For formula values, we use lowercase letters, starting from the beginning of the alphabet like A, B, C, D, and so on. For side measurements for shapes, we use uppercase letters starting from the beginning of the alphabet. For time and velocity values, we use lowercase t and v, and for coordinate points, we use x, y, and z. Variables can be used to create formulas that make it easy to solve expressions that involve integers. Like stated previously, we usually use the letter x to describe an unknown value, but in algebra, we usually use the letters A, B, C, and D to create formulas. In a previous lesson, we talked about fractions, but with variables representing any of the numbers in an expression, we could just follow the formula to come up with an answer for the problem. For example, the following formula is one you could use to add fractions with different denominators. A over B plus C over D equals A times D plus B times C all over B times D. Instead of using the more traditional methods, using this formula makes it even simpler to evaluate the expressions, because you can just plug in the different variables into the output, do some multiplication and simplification, then arrive at the correct answer. We can also do simple operations with variables, the same way we can do it with integers. If x is an unknown number, and I want to add the same amount x to it, then I would end up with 2x. It's the same idea as having one orange, then receiving another one orange, and ending up with 2 oranges. This obviously applies with subtraction as well. What if we want to add or subtract different amounts? If I have x amount of something and I want to give away a w amount of it, then the variable expression that represents this is x minus w. We know these two amounts are unknown, but we know their value is different, so it's required that we use different variables to represent each amount. We could combine or find the difference between various multiples of the same variable. Let's say I pick 5 grapes from a branch, and then 5 minutes later, I pick 3 more grapes. Well, now I would have 8 grapes. The same logic applies with variables. If I have 4x, and I add 6x to it, then I would have 10x. This is called combining like terms. This can only work when you are combining terms with the same unknown variable. The coefficient, which is the number attached to the front of the unknown variable, could be the same or different. As long as you follow the basic rules of operating with integers, then you can easily evaluate expressions with like terms. Variables are going to be a very important part in mathematics, from algebra to much more advanced subjects, so it is a good idea to get practice with using them. In this course, the main variables we will be using are x and y, and we will explain what their properties are in a future lesson. See you in the next lesson.